Well, the topic is whether the UPS will stay on. How important is the UPS with the always requirement of data center? What in data center we call it as an uptime. UPS has always been there ever since I entered the not even data center, the IT industry. The UPS has been there, and UPS is still there. But I will ask all my experts to express their views on this aspect as to what UPS has been and what are the new things that we see in UPS, what changes could take place, or will it stay as it is and how it has been evolving.
Yeah, thanks for. So just to highlight on this latest trend, especially on the AI data centers. So what we are seeing is there is a huge spike in the power requirement from the IT load because of the high consumptions, which is intermittent. And this is leading to high spikes, and then UPS is consistently seeing these spikes and then moving back into the bypass and coming back. And that is where all the suppliers, they are working closely with largest GPU manufacturers to understand how this can be mitigated. So.
Maybe this is absolutely a very, very interesting question. I have been in the UPS industry pretty much over 15, 16 years now. And uptime is probably the fundamental parameter around what you actually design the UPS. The UPS is designed for uninterruptibility. Now, what I can tell you is that nowadays uptime is becoming extremely more crucial, not only from a technical perspective, but also from a commercial perspective. Because we companies supplying UPSs, we need to make sure that we actually compliant to the service level agreements to make sure that as soon as there is a failure or a warning coming from the intelligence of the UPS, we are there immediately within 2 hours on site to analyze everything. So uptime is basically a problem which is not anymore just a technological problem. It's a problem which is impacting us, organization, on 360 degrees. We have to define our setup really to manage all of that. Now, there is another very, very interesting dimension that you actually brought to the conversation. There are different topologies available, right? I mean, a lot of questions about, okay, what is the need of the UPS? There will be a UPS in the future. Is there a UPS today? I mean, I have been in this industry long enough, and I have, at the end of the day, I have come up always with application cases where the UPS is actually fundamental. For a simple reason, of course, there are a lot of hyperscalers nowadays setting a kind of new trend and a new direction, saying, okay, we are going UPS free. However, they have batteries embedded into the server, so they have a different type of an interruptibility function. However, in the moment you play a role in the colocation market and you have certain requirements to guarantee uptime, then no one wants to take a risk. And the only way to avoid that you have a gap into the uptime is to have an insurance, and the UPS is the only insurance you have. Now, there is a third dimension that, if you allow me to comment on, there is as well another question: how will the UPS technology evolve in the next years? So, for example, now we have been talking about artificial intelligence penetrating massively the digital infrastructure ecosystem. I have again come across conversations about the usage and the deployment of DC UPSs rather than AC UPS. Maybe it makes sense. However, what I would like to highlight is that the digital infrastructure ecosystem is so wide that there will not just be one single solution fitting everything. Because maybe the DC could be a kind of evolution for the artificial intelligence application cases, but however, we don't have to forget that we have telecom, that we have enterprise, still very massively present. We have edge applications, and we have as well the traditional cloud-based services collocations. So I would say there will always be a lot of different possibilities for several architectures for sure.
So we heard a lot about UPS involvement, UPS changes. Now what powers a UPS? A good quality battery system. So essentially, if you look at the current system of architecture, you've got the AI scheme that is going on right now. where we have a lot of high power pulses affecting the system. Now, if any of these current batteries get overheated or are unable to support the power system, guess what happens? The UPS would essentially falter, right? So what we would do, we are developing a new scheme of batteries that are essentially support very high power discharge characteristics without getting overheated. So essentially you have a system that will provide you the high power safely and consistently. That's the name of the game. So we have developed systems that are extremely reliable, environmentally friendly, and are safe to operate, both from a user perspective as well as anyone in the marketplace can go in and essentially serve these racks safely. There is no explosion, there is no thermal runaway, but there is just it's about 2x the current lithium-ion, 2x the power of current lithium-ion products, and of course way significantly more important than lead acid, and much lighter in weight as well.
Thank you. As Antonio mentioned, that now most of the server racks, all of these hyperscalers which are now prevalent everywhere, including India, which is they are dominating the data center market. All the hyperscalers in the last 5 years have moved, as he said, away from the centralized UPS systems. Traditionally, we used to have UPS in all data centers next to the data center hall, always two sets of UPS, A and B, and both were giving power to the servers, A power and B power, and the power was going into the server and then being converted to 5 volt DC bus, and all the electronics was working in the servers on that basis. But in the last 5 years, there have been a development where all of these hyperscalers who are now running large megawatt data centers are not using those centralized UPSs anymore. In UPS, what happens, there is a double conversion. Every UPS is known as a double conversion UPS. So we convert first AC to DC and then DC back to AC. And then we supply that to the server racks. And in the servers, there are SMPS, these converters. So they again convert the 230 volt to 5 volt or a 6 volt DC. So there are 3 conversions, first, 2 and 3. To avoid this chain of 3 conversions and losses associated with every conversion, all of these hyperscalers are nowadays using, as he said, DC UPS. These are UPSs, these are converters. These are basically converting 230 volt to DC, and the battery itself is DC, and there are 2 DC RPDUs on the back side of the server rack where all the servers are plugged in. So basically, whether it is in the centralized portion or at the every rack level, the UPSs are still there and they will continue to stay as long as servers are there, because no utility power, whether today or even after 30 years, can give you uninterrupted power. Anything can happen. It's not only the generator or the generation or the power plant going off, it is also the damages or accidents in the distribution system. So utility can never be continuous, and therefore UPSs would always be there as long as servers are there, as long as compute systems are there, and as long as you need almost 100% uptime. However, I'll ask my colleagues to give their last opinion.
Yeah, so just to add on what Mr. NKJ Anthony mentioned, so UPS will remain, and it depends who would be the end user. So as he mentioned, currently the hyperscale customers where they have open compute platform, so they may not go for a UPS, so they could be a direct DC powered rack. And so in coming years, maybe next year, we will see large DC powered racks, because NVIDIA is planning for 600 kilowatt, and then they are planning for 1 gigawatt rack. So 1 megawatt rack very shortly, which would be planned and launched in 2026. So there, the complete transformation would be a DC powered system. It will not be anymore a UPS. They want to reduce the losses. That is very crucial when the capacities are much higher. So obviously UPS efficiency plays a major role. And even though there are a lot of products available in the market which can deliver 98% efficiency in a double conversion mode, so still it will make a major difference of saving energy. That is my view on this, but UPS will remain, it depends upon who would be the client and what would be the classification of the loads or what sort of AI loads they are going to use.
And thank you very much, gentlemen, also for giving me the possibility to further comment on this one. I would like to start with the basic concept that the uninterruptibility function is there, will always be there forever. I mean, it's just that maybe the uninterruptibility is just expressed in a different form and in a different shape. Look at your laptops. You basically have a battery which is embedded into your laptops. And if you pull up the plug of the AC power supply, immediately the battery kicks in. But how does it kick in? Through a converter. So that battery is actually connected to an internal converter which is a different shape and a different form and is producing the uninterruptibility. However, we as UPS manufacturers, we believed on the idea that there will not be just one single solution for every single application. Because we, UPS providers, we have to focus on basically any type of application which is mission critical and critical power, which have different type of requirements. So for example, we also mentioned the requirements of the hyperscalers that have moved a little bit away from the centralized UPS concept. However, most of the times it happens that these are same hyperscalers, when they move into co-location, they oblige the co-location operator to have a UPS, which is actually organized in a standard AC to AC conversion stage. So there will always be a UPS for a simple reason. The UPS is actually a kind of insurance at the end of the day. Another thing that I would like to add, and I fully agree on the concept now, with the deployment of artificial intelligence, digital infrastructures, and going beyond of the actual current power density at IT rack level, which is 30 to 50 kilowatts going to 75. We're already discussing 150. We're discussing for the future 500 kilowatt per IT rack, right? Most likely it doesn't make sense to have one single UPS to supply to IT racks. Maybe we will have to start thinking differently. To be honest with you, how? I don't know yet. I don't have the answer yet, also because this industry is in extreme evolution, and we will see what it can happen, I would say, in the next 5 years. I mean, so far for the next 2 or 3 years, looking at the short to mid-term timeline, I tend to assume that the actual configuration of the UPSs will stay as it is.
So, we have a lot of interesting things happening in the UPS side. Now imagine this, okay, the folks are going to a full DC system. So the backup for a UPS is a battery, right? So we have to evolve our batteries such that they meet the UPS requirements or the industry's requirements flawlessly, right? The idea is to have, as we were pointing out, our colleague pointed out, that the response time should be basically 0 seconds. So it should be instantaneous. So we provide instantaneous power to these UPS systems so that you do not have any downtime. Secondly, there is also the servers are actually having battery packs inserted in those devices so that those packs provide the power, again, on demand. So we have to design a battery pack that then fits in these applications as well. So it's not just prismatic or flat plate designs. We also look at cylindrical designs that fit into these applications that may need specific geometry to fit in. So all that is being designed as we speak with batteries that are extremely safe and extremely user-friendly and finally fully recyclable. So these are the factors we have to essentially glean from what is going on in the UPS industry.
Thank you. I didn't hear the bell, so we can have questions. Yeah, any questions from audience, if at all? Okay, so all are well educated. I think we can conclude this.